like to introduce Dr. Harmish Khambhaita from ANYbotics, Animal is already well known. Probably he does not need an introduction anymore. And with that, I give over to you.
So I will be talking about what we do at ANYbotics. You will also see the robot. And I'm joined by my colleague Andrea. He's already starting the robot, as you can see. I will show a bit about how we approach the industrial inspection, and also behind the scenes how the robot works. So let me start with why. Why are we in this business of industrial inspection? Why we think that the robots are necessary for industrial inspection? And there are three things, basically. There is a huge shortage of workforce. People either leaving soon, they are retiring soon, and not enough people joining. Second is there is billions of dollars and billions of euros lost every year due to the unplanned downtimes. So I think also Professor Fink's group works on finding out how to do this preventive maintenance so we can solve this unplanned downtimes. And the third is actually the leading cause of industrial accidents is by human error. And if we can deploy robots, that might solve this issue as well. So even though there are these challenges, the things are changing. And we have seen those changes also in the past. For example, the manufacturing industry, I think now all the cars are manufactured with this kind of a manipulator robots. So it was already disrupted some years ago. And right now we are also seeing that the warehousing is being disrupted by mobile wheeled robots. And both of them have the similar reasons behind that, which is the workforce shortage, of course, and also the task is quite repetitive and it's very predefined. So you can rather easily program this robot to do just one task. Now we are moving into also automating the whole industry in a sense that the robots can go anywhere where the humans can go. So we want to make them free in that sense. And it's also with the same reasons. There is a workforce shortage I showed you. There is repetitive work, and it's also a structured problem rather than a structured area. Plus, these environments are quite dangerous for humans to work, and that is also one of the biggest reasons that why we should use robots in such industries. And this is exactly where ANYbotics comes in. So we have developed this. Our approach is to use the legged robots, and the advantage with legged robots compared to, for example, the flying robots is they have larger autonomy, so they can inspect an area for hours rather than minutes. And it also is a multi-purpose platform because it's a robot on the ground. You can actually extend on it. You can add other sensors depending on your application. So in a sense, we are trying to bring AI for the real world. And our approach, so ANYbotics' approach in this sense is to provide an end-to-end solution. So what I mean is we work at each part of the chain. So we provide also a mobile vehicle plus the autonomous navigation system and the data capturing and data analysis part. And why this is interesting? Because this would be the fastest way, we think, that how industries can deploy these robots. Because if you had to work with the middleman, for example, let's say, who brings the data capture and data analysis, that would probably slow down. So our approach is to use an end-to-end solution. And here I gave some examples. What this robot can be useful for is, of course, reading instruments. Then through analysis, you can also detect events and prevent events. Of course, it can be used for patrolling, situational awareness. And I will show you also an example of a 3D scanning, which is nowadays getting also famous because of this word digital twin. But without ado, then let me show you how the robot looks. So this is animal. It has all the sensors inbuilt. Of course, it's a 4-legged robot. It can map its environment in which it needs to work. And then also autonomously plan its path from going from A to B. With that, you can build missions such that you can tell it to go to certain places and do certain kind of inspection. Here we are showing that it can detect temperature, it can detect sound, it can also take the images and also analyze them on board. And of course, the robot can go anywhere as a human would go, so you don't have to change the environment at all. And that is also one of the reasons why we should think that the legged robots are more suitable. Here, for example, we are showing that once the robot detects something, it can also tell the operator that something is wrong, and then the operator can quickly go into that place and fix things when necessary. And the robot is also, the autonomy of the robot is also extended by autonomous charging, so it can actually detect the charging station, sit down on it, charge in for 2 hours, and then it's ready again for another 2 hours of inspection. And here in this video, I'm trying to show many areas where the robot can actually walk. And of course, we built the robot completely IP67. If you like, you can go to the website, and we also have a nice video of a robot coming out of the lake. I forgot which lake. I think it was CLC or something. But it's very nice. So it's IP67. And now maybe Andrea will bring the robot so you can actually see how it works. While it is working here, I want to show also, this is not just a kind of a toy. It's, of course, useful to do substantial cost saving in the industry. And I want to give you maybe 2 examples. So I was saying that 3D scanning, so in onboard sensor, this is called a LiDAR device with which it can actually collect 3D data of its environment, and it can then you can place different instruments in this 3D environment, and robot, of course, can go to anywhere in this environment. And another application I would like to show is sometimes in the offshore, where you need to transport the people with helicopters, that could be quite costly. And having a robot over there could already save you up to 50K per trip. And these are the numbers which we found by talking to our customers, and we are trying to help them to actually save those costs. Now, I would like to switch gears a bit, probably towards a bit of a scientific part, but very, very still on the surface. So you have seen how the robot walks. It has actually learned to walk. So there is a neural network behind the scenes. And it is a machine learning technique called reinforcement learning, which we use. So at the start, we give some commands, and then with a kind of just a random neural network, and then it starts to give some motor commands. The robot may fall at the start quite a lot, and then it learns, and it gives a negative reward if robot falls. And if the robot actually walks into the direction, then it gets the positive reward. This way, it can learn over iterations how to walk. So you might think how many robots we have broken in doing this. In fact, none actually, because it turns out that you can offload this learning part into simulation. Nowadays, simulation environments are quite good, so that here I'm showing an example of the same training process. At the start, you can see it can barely stand up. And then after some iterations, about 50, it is able to stand up, and it is able to even do some kind of a trotting behavior. And then, if you give some more time, it starts walking a bit. And as you can see, now it already starts walking. Now it actually follows the command what we wanted it to follow. And then what we do is also we make gradually the environment in which it learns more and more difficult. So here we are changing the heights and variability of the ground such that it's quite robust. It can walk on many surfaces. And one of the advantage of using simulations is that you do not have to just program or learn one robot. You can learn thousands of robots at the same time into the simulation environment. This is actually a video from the lab which we spun off. It's called Robotic Systems Lab in ETH. And they are partnering with NVIDIA to bring this kind of a simulation systems to other robots as well. And in the end, so you get is an extreme mobility in all the situations. So this robot is able to walk over any kind of disturbances, as we can see here. It can also walk into slippery surfaces, and this is sometimes very hard to program by hand if you do it. It's almost impossible. We tried it before. However, with the learning-based techniques, it's quite robust. And it can also, of course, climb hills. We say it is up to 30, but we even tried 45 degree slopes, and it still works quite well. However, as humans can also fall time to time, robots can fall. And it turns out that you can also learn to stand up from any kind of a situation. So here we took the robot on Titlis. We induced the fall. It didn't fall. And then it can stand up by itself, also using this learning-based techniques, and can start walking again. So it's really that you don't have to, if the robot falls, you don't have to go at the place and help it. It can help itself in that sense. And of course, we try in many different situations in the lab to make sure that it stands up from any kind of a fall if we have encountered it. Next, I would like to also show a bit of what I was saying. Digital twin is a kind of a buzzword these days in the industry. And with its onboard sensors, the robot can actually build very large maps up to kilometer squares, and also multi-floor environments. And then it can use these maps to localize itself within centimeter accuracy. And this is actually very important in certain applications. For example, when you need to precisely monitor a temperature at certain places in the industry. So you really need a precision. And on the left side, we are also showing that in certain areas which you have not planned before. So this is a cave where you can remote control the robot, and in the end, what you get is an accurate map of the cave. And you can then, of course, transport this data into more industrial digital twin, because there is not one, there are quite a few. So we also provide exports to those data sets. And then coming to the part of inspection intelligence, on the right, what you see is the data capture part I showed you in the start of the value chain. That the robot moves, it automatically moves its cameras, as at the moment Andrea is remotely controlling. And then from these pictures which it takes, it runs onboard analysis to figure out, okay, this image is showing, for example, here a gauge, or it is showing a valve, and also it can say if the valve is open or closed, what the temperature the gauge is showing. So you have the full chain. It all runs on board, so you don't have to even put it into somewhere in the cloud and care about maybe security issues, if you like. And with that, so we have a complete onboard sensors which already can do a lot of things, but we didn't, of course, stop there, because many different industries would like to use many different sensors. One of the example is the Leica device. Oh, sorry. This is the same what you see. I should have done this before. What you see is the Leica device. So we of course provide tools and interfaces to put it on the to put any other kind of a sensors on the robot. And then, of course, the last part is to export this data. On board, we have, it can generate a XML or PDF sheets or of the whole mission, so it will have all the data with it, all the analysis within it. But you can also go to the other route, which is to sync this data to anywhere into your system, and we found that there isn't one system there. So what we provide is also APIs to take the data out and put it onto your server, and then run further analysis algorithms if you want. So with that, I've showed you or we have already found quite an interest in different, from the different industries. And I think in the next session, the companies which are presenting might have also interest in this robot. This version, as you can see here, it has all the sensors which is necessary to work in the power and construction industry. But while working with the chemical companies and oil and gas, we found that IP67 is actually not enough. What they need is an explosion-proof system. These are the systems which should not be able to generate any explosions in the environment. So we built that, and we call it ANYbotics version, which is the IECX and ATEX certified robot. As this version, the robot it was the first IP67 robot, legged robot. The ANYbotics is the first ATEX certified legged robot in the world. And we see now the application only expanding with ANYbotics. So to recap, what I showed you is how you can measure and take this data into the systems, right? So you can actually remotely control the robot to do the assisted examination, or you can program the whole missions, and the robot repetitively does those missions over the time. Now, what if you want to also act in the environment? What if you can put a kind of an arm on the robot such that the valves I showed you, it can automatically open or close, so an operator do not have to go there. Or you can also do assisted interaction by remotely controlling the arm. So in fact, we also did that with one click. Now you see we showed this into recently a chemical expo in Frankfurt, where we have the arm, it goes, it takes a bottle, it opens it, puts in the place the clutch so that it can collect a sample. This is an example of showing, and then it brings this sample back to a place where you like. With that, I will finish, and thank you for your attention.